All right, so this is 152, and we're down to here. More about getting the investigation started and leads, and then I'll demonstrate the last part of Splunk. That's what I'm going to do. So let's take a look at that. That stuff should be here. All right. And, okay. All right, so when you get your initial facts, you need something, you would like something specific and actionable like IP addresses and times when something happened, and then you know what to investigate in logs and other things on machines. Time zones are a problem. If you have a large network that spans time zones, or if you're using cloud servers in other time zones, then the simple solution is use UTC for everything. Otherwise, you will tend to go mad. Yeah. And all right, so here's some checklists, the summary of the incident, how it was detected, the systems, the network, and the malware. And we'll go through these. So you document this, you're going to have some kind of internal records kept of these incidents. You know, Microsoft has these knowledge space articles in long numbers. You have to have some way to store it somewhere where it can be searched and accessed, typically a file share or something, or wiki or something like that. But you shouldn't trust any part of the target's network. This should be off of the network that has been attacked, of course, because it could be compromised and you don't want the attacker seeing your investigation. And so here's the incident summary. When was it detected? Who are the people that reported it, detected it, and recorded this information, so you can go back and ask them questions later if it turns out you need more information from them. It's the same way police do. First thing they do is go around and record everybody's identity and phone number at the crime scene so they can talk to them more later. And then you have to record the general nature of it, what was affected, and how it was detected. Something happened, like an AV alert or some user reporting some suspicious behavior. Something caused you to declare an incident. So now you need to uniquely identify all the computers involved by serial number or something, and then you want to know who accessed the system since this incident started, so you might be able to tell what those people have been doing, because you might confuse whatever they're doing with attacker activity. So who's aware of it? Is the incident ongoing? Do you need to keep it confidential? These are big questions to answer pretty quickly. And then for the incident detection, how did you detect it? Is it an automated alert or a manual process? What information and sources do you have? And then you have to decide whether it's accurate. There's a lot of funny things that happen on computers. I mean, one of the most common things that happens to all the cybersecurity instructors I know have the same problem. People keep coming in and saying, I've been hacked, hackers are after me, and they often have unconvincing evidence of this. One of the most common things people do is look in their router logs. If you look in your router logs, there's a bunch of attacks. And that doesn't mean you're hacked necessarily, but it does mean there are attacks on the internet. But anyway, that's the thing. Often you have suspicious things happening, but they are not real incidents. They're just the normal background traffic of crazy things happening. And then the question is, are you preserving this data? That's one way to describe computer forensics, is capturing data and preserving it for later, making a good copy of things. In incident response, you're not trying to get all the evidence like you are in criminal investigation, but you're trying to get some evidence, and you do want to save it. So, check your detection sources, who runs them, how reliable are these detection sources, has somebody changed anything? It might just be that somebody updated the virus definitions in your IDS and it's picking up false positives that it wasn't picking up before, things like that. All right, so your individual systems, you want to know their physical location, some kind of unique number like whatever asset tag you use to keep track of your things to know if they're being stolen, who the person responsible for it is, and network information, and what information you've got and what backups exist. These are things you should know about. You may need to go examine them. And whether it's still connected to the network, a list of what malware is detected, which will be your antivirus logs or endpoint protection, and a list of whatever people have done to try to fix the problem. They might have tried to do things like re-image it or uninstall things or run some kind of antivirus cleaning program. And again, if they're doing all that, then you will need to know that they did that and that wasn't the attacker doing that, because the attacker will often do the same thing. Sometimes attackers run antivirus to get rid of other viruses. They change passwords, they create accounts, that sort of thing. So the network information, you want to know any malicious IPs or domain names. Those are the very valuable indicators of compromise. If the infected machines are actually connecting to an external address you can find, then you can analyze the network traffic and find out which machines are infected. So that's great if you have network monitoring. And again, check your network diagrams and configurations, because networks are now very complicated. Everybody has VLANs and filters and firewalls, and network traffic often follows a circuitous route going out. In fact, there was a news article that came out a few days ago where it was Facebook. Someone said, you know, at Facebook, I tried to find out where the personal data is, and nobody knows. The network is such a mess that nobody really knows where it is, how many servers it's on. You can't even keep track of where it's all going, and various people are getting upset about that. But anyway, all right, so then if you have malware, you want to analyze what you can about the malware, how it was detected, where you found it, file names and directories, and the malicious file, if it's active, if it's still spreading, then what network connections is it making? That's the sort of thing you'll want to know. And preserve a copy of it if at all possible. There are some famous malware cases like wipers. Around the time of Stuxnet, there were a bunch of attacks in the Middle East that were wipers, which may have been related to Stuxnet because they couldn't get the malware, but when it was done, it would zero out the whole hard drive and destroy the machine. So I think that may well have been part of the Stuxnet attack. They didn't want to get caught. But anyway, they didn't catch the wiper, but they knew there existed a wiper. And sometimes you're able to get a sample of the malware, and sometimes you aren't, because it deletes itself before you can get it.
The Huawei hack was also like a wiper.
The Huawei hack?
Yeah.
Huawei. Huawei got hacked. Oh, yeah, with wipers. Yeah.
Yeah. They were after they one time they delete itself.
Yeah, and that's one way to hide the tracks.
Not delete the whole file, but just delete itself.
Yeah, you can also wipe the whole machine and delete. That's right. Deleting yourself is a common trick because the bad guys don't want you to get the malware, of course. So anyway, if you did submit malware to a third party like VirusTotal, then you should know that, because that may affect what the bad guy does. So you should be aware of that. Mentioned before, this is probably not a good idea, but if it has happened, you want to know it's happened. So record everything. This is real important in all kinds of forensic work. You just keep thorough notes of everything you do, because anything you do may come up later. There may be lawsuits, there may be criminal trials, and your notes may be evidence, and you may have to testify, and they will say, what did you do? And then they'll decide whether what you have proves anything. So you want to have notes. I used to keep a lot of notes in my financial work, and when I started, I would put jokes in there, and I learned to knock that off because that might go to court. So, but you do need to have thorough notes of what you did, and you may need to defend what you did later. And if you do something wrong, write it down honestly. Record it. I made a mistake. I wiped out the thing. That's why this is blank. There's no hiding it. But lying about it is the worst thing you can do. You have to record what you do. Nobody's perfect, but make sure you record the truth, and then you can say what you really did. If people get mad at you for doing the wrong thing, that's better than if they get mad at you for lying. Anyway, so here's an example of a timeline. So this event actually happened in November 2012, but they didn't detect it until the next year in May. So here's the, in May is when they're adding all these events to the timeline. So here's where they decided it all started. Bob Smith opened an infected email attachment, and they found this from the file system and the recent documents list on his machine, which you can find from a forensic tool examining an image of a hard drive. Then they went to the metadata into the prefetch folder, and they found ipconfig in there, which means the prefetch folder keeps a record of the last 128 programs that have been launched on your machine. And for an office machine, people usually only use the same 10 or 15 programs over and over, so it can go far back. And normally they would not execute ipconfig. I mean, that's a command line command. Only a network engineer would do that. An ordinary end user wouldn't. And they certainly wouldn't run this, gsec dump. That's a credential dumping tool, sort of like Mimikatz, that you can download. So clearly, this is the malicious guy doing something. He ran an infected email attachment at 1816, and 4 minutes later, the bad guy is on here, or running the part of this script is executing ipconfig to get network information, and then trying to dump credentials off his machine. And then the next day, he called the IP department to report the suspicious email. And then in May, they collected live response data. So he did report something, but apparently they didn't decide to call it an incident at the time. It just went in a log of people complaining about email, and something caused them to actually do more of an investigation later in May. So anyway, this is the sort of information you'll have. Yeah. All right. I see, yeah, Facebook has now got TV ads claiming they're protecting their privacy. Yeah, well, that is their sore spot. I can see why they would want to try to convince people of that, because their reputation is very bad. Anyway, so here's your priorities. As always, you have to know what you're trying to accomplish. The normal priorities are, some people might want to know who broke in. Often you're better off not even worrying about that, but know when it happened and what they did, and are they still inside. These are really important. Knowing who they are is actually not that important, because you're not going to go arrest that one person. Even if you could, that's not going to solve the problem. You have to block the vulnerability that let them in, or somebody else might come in the same way. So there are special cases sometimes. If you have payment card information, then you're going to have a list of the account numbers and dates, because you may need to notify those people that their credit cards have been compromised. And you're going to have to check with your legal counsel for issues like that, and copyright infringement and larceny, if you want to prosecute people who are like stealing money and such. So you may have legal considerations of what kind of data you want to get and how you want to preserve it. Anyway, you have to work with management. Management often has unrealistic expectations, and you have to control that. So the investigators know what is reasonable, the type of evidence you have, the type of incidents you have. Network intrusions typically jump through many intermediate servers in foreign countries, so it's usually impossible to figure out who did it and impossible to punish them legally. Unless you are the military or the police yourself, you probably have no ability to do that, and it's probably pointless. Also, if like that example from before, you don't even notice it for months, then most of the evidence is going to be gone by the time you're investigating. And that's again going to mean you better explain to your management that you're really not going to find out too much about it. So here's an example. Someone ran an automated vulnerability scan on a web server and found a management interface. They managed to enter through the management interface and gain the right to add files to the system. So now they've set up a wares site. This happens pretty often. They're selling something illegal or malware or pornography or something from your server. So now they were selling stolen illegal files from the company. And so the management found out, and they got very mad, and they wanted to prosecute the attacker. And this is where, your incident response team would do well to talk them out of that. The fact is, tracking down who did it and jailing that person is probably very difficult, maybe impossible, and it doesn't actually do your company any good. The fact is, you have a vulnerability, and somebody else could come in the same way. You need to solve the problem by finding the vulnerability and patching it. That's how you keep this from happening. That's why it's not actually tracking down the bad guy and taking revenge on them is kind of a waste of your time and an indulgence in most cases. Well, let's take a look at a Kahoot. Guess I can put it in another tab here. Favorites. Oh, not in favorites, that's the problem. There we go. 152, chapter 4. I think that's where we are. We are, good. looks like that's it. Okay. I'll give it a few more seconds. All right, which one is false? Yeah, it's unusual for them to have an insider. It's not impossible, but that's not as common as these other activities. All right. All right, which step is not normally performed for individual systems? Yeah, that was from the real college several years ago when we had a crooked CTO that staged a fake virus outbreak on campus. He claimed all his machines were infected, and when various people like me and the network administrator came to him and said, "Let me see these machines," he said, "Oh no, I've locked them up for the FBI to analyze. Nobody can touch them." And that is garbage. Nobody does that. That's nonsense. But that's what he said. Anyway. All right. So which detail is not normally important? Yeah, and of course this one is growing in importance as we have blockage against Chinese network gear and stuff. We're getting more and more worried about what nation the hardware came from, but again, it's not as big an issue as these other things. All right. I don't know who that is. That I don't know, but if those are real initials, my grader may find you. I don't know who that is. All right. All right, let's go back to here. Good, at 6:30, we're fine to keep going. All right, so then you gotta have leads. So leads are information that gives you something you can work with to find more useful information. You know, that's some actionable item, like a network indicator or the identity of people that are involved, or some issues, something that gives you some direction in which to investigate where you may find more good stuff. So it has to be relevant to this incident, it has to be actionable, something you can actually do something about, and it has to have enough detail so you can make some progress. So first you clarify the data, make sure you understand what you are being told, then you go make sure it's true. You check to make sure it's not just a misunderstanding or a falsehood, and then the context, and then you can figure out how to exploit this lead. So for example, if your network intrusion detection system generates an alert, that means it has detected some suspicious network traffic, which it calls connection to a command and control server. So try to identify what machine it came from, if you can. Your network address translation might make that difficult. And then you can look at the raw packets to see if it's really sending what looks like beacons to that machine. Look for other connections sent by that host in the network logs, or inspect that machine directly. And then you can get a clue whether it really looks like that machine has actually been hacked and is actually doing something malicious or not. So when humans are the source, when you have a human telling you something, then of course you've got to issue interviewing a human suspect. They might be just misinterpreting things. And so, of course, automated systems like network intrusion systems also misinterpret things. Oh, I see. AA has told me who they are. Let me make a note of that. Good. I got it. All right. So, So you want to turn these into viable indicators so you can detect ongoing events and detect more suspicious conditions beyond what you already have. So you want property-based indicators are nice, things that you can easily measure on a machine like registry keys, hashes of file values, mutexes. Mutexes, by the way, we talk about in the malware analysis class, mutexes are handles in the memory. They are just memory objects which can be viewed by many processes. There's a process isolation feature in all operating systems, so one process does not enter the memory of another process. But if you do want to send a signal from one process to another, one way to do it is by setting a mutex, which can be read by other processes, and malware often marks your machine with a mutex so that if you reinfect the same machine, it detects that it's already infected and doesn't try to infect it a second time. So a lot of indicators of compromise include mutexes. So then you might have less specific leads than a particular file or registry keys, things like unexpected executables in a strange directory or things like that. Things that are more vague, but are also look suspicious. So you've got an initial lead. You have some information. From that, you try to create a more specific lead. You verify it. Then you have to test, is your data relevant to the indicator? Does it, in fact, to correctly detect infected machines? And then you have to see, does it false positive? If you look at clean machines, do they trigger on your indicator? Then it's not good. You want to make sure that your indicator does detect a compromised machine and does not go off on other uncompromised machines. Once you've got an indicator that passes these tests, then you can publish it and deploy it to the fleet and see what machines show that indicator. So these are host-based indicators, and what you're trying to do is just, is it compromised or not? You want a yes or no answer. So you want to assemble some observables that will identify it. So here we're going to use a malware sample from this book, which is what we're using in CNET 126. This is the official Mandiant Incident Response class, and that's the official Mandiant Malware Analysis class, so the two books are related and working together. So this is a executable, and it's got this MD5 hash. So one thing you could do is just say, go through the whole file system, calculate the hash of every file, and if a file has this hash, then it's infected. Now that's good in the sense that it's not going to have false positives. You're not going to find that hash unless it's infected with the malware. The problem is any change in the malware will cause this indicator to fail, and the bad guys can easily get around it by just making a small change in the malware. So this won't be too effective for long. The next version of malware, it won't detect it. So another way to do it would be to look for the portable executable headers. We're talking about this a lot in the malware analysis class, but here's the executable files in Windows, exe, com, and del, and those are all portable executable files. That's the container concept of what they are. It's the file format they have, and in the header of the portable executable file is a general information about the file, in particular listing all the libraries it uses and all the functions it uses in those libraries. So you could do that. It also has the time date it was compiled. So you could say if the MD5 matches or the date matches and the file size matches, then trigger. Now, so this might work if there's another version of the malware, if they made a series of them at the same time. But getting to working exactly this time and exactly that size, it kind of suffers from the same flaw as just the MD5 hash. Even a minor change in the file might cause these to not pick it up. So you might do better to go here. The malware, in fact, has network traffic, and the network traffic goes to this practicalmalwareanalysis.com domain name. So now you're looking a lot better. So if you find that hash, then you're infected, or if you have recently resolved this domain in the DNS cache, then you're infected, or if I find a service running with this name, which the malware creates, or I find this file name and the header having this date, or the file size having that, these are various combinations of conditions that are suspicious, and now it's more general. Now it will survive quite a few minor modifications in the file. So that's what you might do to make a better indicator. So you're trying to make a balance here. You want to have enough information to detect the file, but you don't want your rule to be so complicated that it's going to be too slow to run. If snort rules, by the way, snort rules use regular expressions, and it is very easy to write regular expressions that are very, very expensive to calculate, that can actually cause a denial of service condition when it tries to go through all the implied branches to hunt through it. So if you get too fancy, you're likely to make a rule that is too expensive to use. So the import table is part of the header. This lists all the libraries needed to run the program. And Normal programs use common libraries that are convenient for developers. Malware often uses strange libraries that are not commonly used by developers, so this is something you can do to be suspicious. Here's the import table for that piece of malware. Create service, reg create key, read file, create threads. You might say if it's using all these functions, then that makes it suspicious. Now, you might find that there are innocent files that pass this test. So this might suffer from false positives. You'd have to test in your environment to see. But it might be that this particular combination of functions is only used by the malware. And then, of course, unless they make very large changes in the malware, it'll still pass this test. So that's another way to go. All right, and then there's non-malware IOCs. You can detect malicious. Now, a lot of people do not use malware anymore. They call this living off the land. Your more professional attackers will just use Microsoft utilities. Is this a snort rule? One of those was, I don't think there was any snort rules yet. These are just sort of written in sort of pseudocode. They're not even any particular language. But the snort rules are in a particular format. We'll see one later. You can do all these in snort, but it's sort of confusing to read. Anyway, so here's, let's see, there's a link here. Microsoft Iranian hackers encrypt Windows system using BitLocker. Yeah, that looks like related. So anyway, this is the point. Bad guys now just use non-malicious programs to do things. So here's one, for example. This is one way to hack into machines. SethC is the handicapped accessibility. If you can't type on a keyboard, you hit the Shift key 5 times when you're logging in, and it'll pop up like an on-screen keyboard or something. And so, therefore, if you can replace this file with another file, it will run before you've logged in. So what you do is you replace it with cmd.exe. This was real popular up until about Vista or so. Now when you press Shift 5 times, it will open a command prompt as system before you've logged in. Now you have system privileges on the machine, and you can make an account and log in and do whatever you want. So there's another way to do it by adding cmd.exe to a debug handler in the registry. These are 2 ways to modify this file and thus get a backdoor into the machine. So if you want to detect those, you can just see if the file here does not have the expected hash. Now, if all your machines had exactly the same version of Windows, like in your book it's Windows 7 Service Pack 0, then they would always have exactly the same file here. And if that file doesn't have the right hash, then it's infected. Or you might also look at the time date. Time date is modern and not the right time for this to be written. That's an issue, but of course if you have different versions of Windows and Windows updates, that file might change. So if you had the old one version and another version, you could have 2 different hashes and 2 different dates, but this is going to get out of hand pretty fast as you have more and more. This is the general problem with allow listing. If you have an allow list, you have to allow all versions of everything, and since everybody's always updating and patching stuff, it keeps changing, and your allow list has to be kept up to date and it keeps growing bigger. So another way to do it would be to look for a more simple general solution. And one thing is, in practice, they replace it with CMD, and CMD is always bigger than Seth. So all you got to do is just see if the file there is bigger than it ought to be, then raise an alert. That's a whole lot simpler, a whole lot faster to run, a whole lot more likely to work. All right. You can, if you want to look for the debugger key, you can just look at the registry key that connects the debugger and see if it has sethc.exe in there, which it shouldn't have, and if it does, then that's another clue that they're using it to perform that other attack. And so here's the OpenIOC format of these things, and these 2 things. Registry path contains these. This is that OpenIOC format they've talked about. I've never seen anybody actually using this, but it is an issue. Also, the file properties can be changed to escape the IDS. Yes, that's true. Yeah. Yeah. Oh, I see somebody talks about living off the land. Yeah. Encrypting a machine using BitLocker. Okay, good. All right. And so, your network-based indicators are, of course, very nice. If you just look at network traffic, then you can find the bad ones. So maybe you want to look for certain bytes of a session. That would be one way to do it. There's some kind of characteristic bytes in the network traffic created by the malware. That might work, but maybe if they edit the malware, it will change. So another way that's usually easier is use DNS. DNS is wonderful. And if they are not using the newer DNS over HTTPS, which is why a lot of security people hated the move to that, then DNS is not encrypted, and you have a clear record of all the domains that are resolved, and you have a time when it was happening, and you know what machine it came from. So you just look for, is anybody going to this malicious domain? If they are, they're infected. That's a whole lot easier. This will be the query lookup. So if you look at it, here's the layout of a DNS record. It has a UDP packet, and in that packet it's got a query name, query type, and query class. This is the layout of it. So the QName format is like this. It's split into two pieces. You have the length of it, which is 18 in, I think, hex, and then this part, and then length 3 for the .com part. You break each of the parts of the domain into pieces. This is the way it actually moves over the traffic. Does DNS or HTTP show in proxy logs? Yes, it would. So if you want to let your people use DNS over HTTPS, and you still want to monitor the DNS, then what you want to do is force them to use your official DNS server and no other one, and then log on that server. And again, you'll have the useful information. That server can log it. Even though the network traffic is encrypted, the server will have good record. This is a very good question. And it's, by the way, another reason why a properly managed network will not let you change your DNS to just some public thing like 888 or 1111. Every place I use lets me do that, but a properly run company would not let you do that. They would force you to use their official DNS server so they can log and so they can restrict it. They can then block, say, malicious domains there, and you won't get through. That's why just letting people use a goofy DNS server that's not under your control is not usually a sanitary policy for your network. Anyway, this is what you're going to see on the network traffic. You won't see the domain in the form of practicalmalwareanalysis.com. You'll see it like this. This is what Wireshark will show you. This is the DNS query to resolve it. It is practical malware analysis, but before that it has 18, which is the length of it. And then instead of a dot, it's got a 3, which indicates there's 3 more characters. So that is the actual binary pattern you'll be looking for in the network traffic if you're looking for DNS packets that are resolving this domain. So this is the snort rule. That's what snort rules look like. This tells you what network is being scanned and from any IP address to any other IP address on port 43. Send this message when you find it. And here's the content. A binary 18, then practicalmalwareanalysis.com, a binary 3, and then com, and then a null byte. So it's going to look for that pattern of bytes in the traffic, and if it finds it, there's other information here like how many it will take to trigger it, and so on. But anyway, that's what snort rules look like in the general format. All right. And so then there's dynamic analysis is another way to do it. So start monitoring the network, loaded the library into the system and called the method install A. This is running the malware. Waited until it performed a DNS lookup and verified that it actually made a query to this domain. Added this into a phony DNS server, pointing it to a Linux system, so it'll log requests. These guys are doing it in a sanitary way. They're not letting this thing phone home to the real malware control center on the internet. They're using something like inetsim to avoid that. Then they reloaded it and called the method again and observed that it happened again and made a GET request for this. So now they have verified that when you're infected, you will make this network traffic with these properties, and that's the indicator of this piece of malware. So that's the kind of dynamic analysis you might do on the malware to develop this indicator of compromise. So then you want to verify it. Before you waste your time scanning all your systems, test it on some machines. First, test to make sure that it really does trigger on the infected machines, and then try some clean machines and make sure it does not trigger. Otherwise, you're going to waste your time and confuse yourself by getting a bunch of false positives or false negatives. And if it passes a test here, then it's probably worth deploying with some tool like Velociraptor that will, or just scanning. In this case, it would probably be Splunk to scan your network for that network traffic, or Snort. Anyway, so here's an attack lifecycle. For example, you send an email with a malicious payload. It's an executable file that looks to be a Word document. So the user launches the Word document. That's actually an executable file, which drops a normal Word document, which opens so the viewer will see a Word document and think that's all that happened. But in the background, it will launch a second stage script, which will do something. It will remove the dropper and then do more malware, probably download more stages of malware doing more bad things. So it's the kind of thing you would typically see. And so now if you want to detect that, there's various ways to do it. One thing you could do is look for the dropper, which is the original file, MD5 hash and file name, and you might be able to see the email carrying that coming in. But of course, if what you see is email coming in, you're going to waste your time on a lot of machines because a bunch of people are not going to click on the attachment. So the fact that the email went to them does not mean they're infected. And it's going to delete the dropper later. So here's a more effective indicators. Look in the prefetch directory. That will prove that something was actually executed on that machine. That's what you want to know. Look for the innocent Word document, the most recently used registry key, because any Word document you open will show up as a recently used Word document, so that would tell you that they did open it. If it fetched a file, you might be able to find that in the browser history. The DNS cache entries might show you the DNS names that were used to fetch these files, or the metadata for the second stage malware. These are much better because these will find machines that actually did run the malware and get infected, not just machines that got the email and might not have opened it. So test it on some clean workstations and make sure they do not trigger it. And if they do, then you're going to have to modify your indicator to get rid of those false positives. And then another thing you do is see how much resources it runs to run your indicator. If it's something simple, like just looking for a file to see if it's too big, that's easy. But if it's something like a complicated rule with many branch points, it might actually slow down the machine. And if you can bring down important systems with your scan. So that, of course, your customer won't be happy. All right, so then from humans, if humans are telling you what happened, then document anything they say. Let them tell you the story. Don't lead them to where you want them to go. Find out what they've got. Avoid leading questions. Avoid questions that just have yes or no answers. You want to prompt them to tell you what they know. Now, you also don't want to let them go into opinions, and because they probably aren't technical enough to understand, unless they are, but mostly you want to know what did they really see. Same thing when you interview witnesses in court. You want to know what they really saw. You don't want to know their ideas that are not proven. You want to know what they actually saw and what they actually did. But that's the game. And you'll know when you have to get other people involved. All right, and if you have external people that are not company employees, they're not required to tell you anything. So they might tell you things. They might just say they're not allowed to say anything because they don't want to take the legal risk of exposing anything. And if you are a private company, you can't force them to talk to you. You don't have the ability to issue subpoenas or court orders or anything like that normally. The cops and law enforcement agencies can do that, but not a private company. So you can't really make people talk to you unless you file a lawsuit. Now, you can file a lawsuit and then subpoena the provider organization. This is how you can get things like email and Twitter accounts from cloud services. You can use discovery mechanisms. There will be a discovery order in the early stages of a lawsuit where the judge will order people to hand over all documents related to this activity. If you have copyright infringement, then there are some procedures available to demand information. Another thing you can do is report it to law enforcement and hope they will investigate it. This is, of course, a real iffy thing because you don't control the law enforcement, and so you don't know if they will investigate it. And you also don't know what they will do. And if they decide, for example, that it is your fault and start investigating you, you might be sorry you called them. So, you may not want to do this. You have to carefully consider and make sure you got authorization from your legal team and your top executives before you involve law enforcement, because that might cause unforeseen problems. And you want to make sure that you are properly authorized to do that. So your legal counsel can file a complaint. This will compel people to hand over information like ISPs or social networks. All right, and like I say, reporting to law enforcement, generally you avoid it because if you charge to law enforcement, it will probably end up in some kind of public record, and that will just create the scandal you're trying to avoid. The reason why you're investigating the incident is to try to fix it and hopefully avoid being in the headlines as the latest company that got breached, if you can do that. So exposing this information to the world unnecessarily undoes the thing you're trying to accomplish. You're not usually required to report it when you get hacked. You are required to notify it if personal data was stolen. You have to notify customers. And if you find child pornography, then you must report that immediately. But this is a big legal issue fought in the government right now. There's not much in the way of breach disclosure requirements in America. They're trying to put them in Europe, but you're not really required to tell people. However, for child pornography, there's a special website, Department of Justice. You must report that. And you hand it over to them and your investigation stops. That's the end of it. You don't want to touch that stuff. It's a crime to have it. It's a crime to see it. You just have to move that to the government and forget everything about it. But normal things, like a malware infection, somebody tries to steal money from your company, and maybe they even steal some money, you're still not required to report that. All right, so you have foreign entities, ISPs, especially in other nations. If you want to get any information from them, this is very difficult. You can try to make requests, and only if you can get federal or state law enforcement agencies involved are you probably going to get anything. So law enforcement, of course, has the ability to actually demand that people do things, at least within their jurisdiction. They get a quicker response, and they can also get data without notifying the target. They can find out like your Twitter account or your Gmail without notifying the target. And this does not cost your organization anything, or maybe a small cost preparing them. So that's one possible advantage. But typically, they will not bother investigating anything unless it's really important because they don't have many resources. So I remember like 10 years ago, I talked to law enforcement agencies, and they said, we won't investigate anything that caused less than 6 figures worth of damage. If it didn't damage at least $100,000 worth of stuff, then it's too small for us to bother with. It's like if you go to the cops and tell them they stole your bicycle, they're like, okay, we'll file a report, but they're not going to do anything about it because it's too small an issue to be worth their time. Anyway, all right. So if you are going to have law enforcement, then you want to document everything carefully and maintain chain of custody, so the evidence can be useful to law enforcement. Make sure you have a clear picture of it and convey it in a clear manner. And so there are ways to get contact with law enforcement agencies. If you're going to involve law enforcement, you should have a friend on the force. You should have somebody that will answer the phone that you can talk to. InfraGard is a way to make contact with FBI agents. It's a public-private partnership. You can join InfraGard, and then you can go to meetings and meet these people. The High-Tech Crime Investigators Association I'm in, you can get in them, and then you go to these meetings and you meet Secret Service agents and FBI agents and stuff. Then you know people. There's other groups here. This is something many people do. You do want to have contact with law enforcement because, of course, if you find something really bad, like a national, critical infrastructure being hacked or something, then you need to work with law enforcement, and you need to have somebody somebody you can talk to. Otherwise, if you're just calling out of the blue as a stranger, then their first suspicion is going to be that you're the criminal, and you'll have to get through that barrier. But if you know somebody, you might be able to get over that barrier more quickly. All right, let's take a look at another Kahoot. 152, Chapter 5, that looks like it. Occurs to me I didn't exactly answer Dirty to ask a question. Your proxy logs probably would not show the DNS or HTTPS, it would be encrypted, but the DNS server itself would. Unless you're man-in-the-middling HTTPS and decrypting it, which is a good policy, but only the larger networks are usually set up that way. I'll give it a few more seconds. All right, so Tripwire sends an alert. Tripwire is software that detects changes in files. It's a false positive, so what's wrong with it? That's a lack of veracity, they call that. It is not true. It told you there's something wrong, and there's really nothing wrong. It's just something ordinary like a normal update that changed a file. So that's when you don't have veracity, the alert is not true. All right, every program and service in Windows is this kind of file. PE, portable executable. All Windows executables are portable executables. All Linux executables are ELF. EXE is a special case. All EXEs are PEs. PE is the container format that includes EXEs, COMs, and DILs. All right. All right, so what protocol gives the easiest and fastest indications of malicious activity? Everybody loves DNS. It is so easy to understand. You look for the domain, you know who's been going to that domain. All right, so which one of these is in the PE header? The import table lists all the library functions that that file needs. All right, good. Now, kids want to tell me who they are if they want their points. The battery is ready. All right, good. That's it for this. Let me stop this recording.